you wind up calculating that. You take the distances, the separation, the amplitudes, and you can use that onto a graph and come up with the magnitude come up. This would be a magnitude 5 earthquake, or 32,000 tons of TNT equivalent. All right? But that's what that Richter scale means. Now, normally, if you hit something like about in here, you won't have any real significant problems. It's when you get to this point and up, because every time you go up one notch, you increase the total energy used by 10 times. In other words, a Richter scale 6 is 10 times stronger than a Richter scale 5. And that's 10 times stronger than a 4. So, okay? Any real questions so far? Going too fast? Actually, I'm just trying to do my red. Okay. All right. Now, how does this happen? How does it create damage? Remember, we have the surface waves that are most commonly the ones that do the most damage. And this is why. In other words, you have a wave go through here. And what happens? You actually are shifting the foundation of whatever buildings are present. All right? So this is fine. You tilt it. Then all of a sudden it goes through and it's already moving this way, and the second wave hits. Now what have you got? You've got this sort of thing happening. The third wave hits. And pretty soon you're snapping that sucker just like a whip. And the stronger the waves are, then the greater the amplitude back and forth movement. And therefore the more potential hazard or danger there is in terms of the earthquake itself. So this is what we've got happening. And these are some of the results. This is not Davis County Hospital. It just looks like it. However, if we ever do get a 7, a 7.5, or an 8, it would well be Davis County Hospital. This is not the Owensboro Bridge. It just looks like it. And this is always what happens. Can happen. And this is what happens to whatever's underneath this when it fell. Now this here is in Utah. It's about 35 to 40 foot scarp. In other words, it's a place where the earth actually shifted and moved upward. Anybody know any place around here that may have ever happened? Way down the parkway, yeah. Anybody like fishing? You ever gone to Reelfoot Lake? That's why it's there. It's an earthquake of 1812, 1813, 1814. The earth shifted 40 feet. Actually, the Mississippi River ran backwards for a while. It shifted so badly. But it shifted 40 feet, cut off all the creeks, and the creeks had filled up behind it, so Reelfoot Lake is there because of the earthquake at that time. And this is the type of thing that happened. There was a scarp, as we call it, built or developed. And that will happen quite commonly when you get into unconsolidated sediments. What kind of sediments is Owensboro sitting on? Unconsolidated sediments called sands and gravels and clays. So we'll go into it further. But this is the type of thing you have there. Physical displacement. The waves can not only do that, but they can also change the level of compaction of the soil, the ground itself, and that is when you start having collapses like these. Or these. Another situation that creates more damage and is more potential hazard for this area. We're far enough away that if we have something like a 3 or 4 Richter scale, we just barely feel it sometimes. You get to the 5s and 5.5s and 6s, then we begin to get shaky, because the further away you are from the epicenter, the point on the surface, then the less that shaking will impact us in the bedrock. If you're in unconsolidated materials, sand, gravels, clays, and so forth, that's not necessarily the case. Instead, what happens is you have this feature. This is the original compaction level. In other words, everything's set up for compaction. You shake it up, and this is what you get. How many of you ever taken a bucket of sand and fill it about 3/4 of the way full of water? The sand looks solid, right? And twist the bucket. We use the same thing sort of when we want to make something very smooth. We'll shake it up and lay it out so it flows out instead of flows out. We call it liquefaction. And that's what happens to normal sediment, sands and gravels and so forth. When they've got water in them, and either they have clay over it or they can't get rid of the water, it shakes it and it changes the compaction level like this, and you begin to have these things happen. In other words, the entire ground just disappears, sloughs away. You have this sort of thing happening. All right? And then when that happens, what happens to pipes and sort of the materials that are underground, water pipes, gas pipes, electric lines, poles, electric poles, what happens to them? They start sparking, they start breaking, and you have these things happening. So you've got what we call subsidence of landslide fires take place when you have this impact hitting an area like ours. This sort of thing. And this is not the Ohio River, but it could be. It's exactly similar to it. These foundations, roads, schools, fires. This is probably the most dangerous element because he will continue long after the earthquake goes right here. Fuel lines are knocked out, power's knocked out, no fuel. These are the types of things you need to be prepared to handle if and when, I won't say if, when a problem of this sort hits. We're going to concentrate on earthquakes tonight, but this could be a tornado, it could be a hurricane, it could be a major blizzard, it could be any sort of a natural disaster. In the back, you see a whole batch of stuff back on those tables. That's disaster kits. We're going to what should be in them here as we get through. And my wife has put together for us, the two of us. And we'll go into some of that a little later on too. But these are the types of things that will take place. And this is the type of thing that is the most potential hazard for Owensboro. These. Because of the types of geology in which the town is sitting. How many of you have brick houses? How many of you have frame houses? How many of you have a concrete block house? All right, now, which of those three do you think would be the safest? Oh, good. You're already ahead of me. That's correct. The brick houses are probably the worst places to be. Why is that? Because they tend to fall off. If you go down 2nd Street here in Owensboro, what kind of 2 and 3 and 4 story buildings do we have down there? The old brick windows, the old Kresge's, Newberry's, McAtee's, the churches down there, they're all brick. What are they sitting on? This stuff. Therefore, downtown is not the place to be if you're in an earthquake. And for that reason, then, there are places that you should not be, and there are places you would be best. If you're out in the country, you're most likely to be on bedrock. Bedrock is much safer, or close to bedrock. The ex-vineyard we used to have out here, we have 10 feet from bedrock. But the house was on bedrock. We dug a 10-foot basement. It was set up. Over there, the whole area, you've got 110 feet of rock. I know that because I helped put in the 3 water wells on the far side over there. We drilled wells there. You go up to the Davis County Middle School, same there. Except there you have about 10, 15 feet of sand and gravel and have water in it, clay, and then it's saturated below that. And that saturation point is where most of this kind of bad stuff like that will happen in here. So anywhere along the river then, in Owensboro, from Maceo at least, by the time you get to Hallsville, you've got rock all the way out to the river there. But as you move further south than that, as long as you're in that region, and as you get closer to Bon River Hills, there's a thin rim out there, but that whole region between Bon River Hills and Hallsville are areas where this type of thing would be very common. How far inland would it go? It depends. In other words, if you're out in Panther Creek, you could have problems like this, because that's the old valley of the Green River. It used to be out there. If you're down 4th Street at Davis County Middle School, you could have these problems. If you're out at Parrish Avenue, you wouldn't have as many problems there. But if you go further than that, on the other side out to the mall, there you would have problems. So depending on where you are and the relationship with the geologic character of that subsoil, when an earthquake hits, is a control of what the dangers, what the differences are in potential impact of the pulse itself. Now, the pneumatic we finally got here. Okay? Now, what is a pneumatic? These red areas here represent the worst or highest hazard for earthquakes in the United States. And this is where we are, right Charleston, South Carolina. 1886.